One of the challenges of hex meshing is preparing the geometry such that it can be hex meshed, and this involves defeaturing and decomposition. Today we're going to look at a couple of power tools that help the user determine what's meshable and not meshable, and then if it's not meshable, what might be wrong with it, and suggest some possible solutions. To do that, we're going to import a model called Knuckle, which is part of the Fast Start tutorial. So I will go ahead and import that file. We'll use the default settings, and there it is right there. The tools that I'm going to use today are this one here, over here in the Power Tools section. It's called Diagnose Geometry, and I'm going to use this one also, Diagnose Meshability. I'm actually going to start with Diagnose Meshability because when I use this tool, Qubit will issue what's called the Auto Scheme Select command, and it will go through the model, and that could be more than one volume. In this particular case, we're only using one volume, but it could be multiple volumes, and for each volume will indicate whether it can be automatically mappable, sweepable, or submappable. And if one of those things is the case, we consider it meshable, and if auto scheme does not work, then we consider the model to be non-meshable. So in this particular case, I've got by default all volumes selected. I'll just hit the Analyze button, and Qubit ends up producing two lists. One of volumes where the mesh scheme is set, and one where they're not set. In this particular case, we only have one volume. It's not set. And it also turned that volume tomato red. If there were a volume that is meshable, then that volume would be green. That way, in a complex assembly, you can very quickly determine what volumes you need to focus on in terms of defeaturing and decomposition, and which of those you can ignore for the short term. So we know that volume 1 is a problem. So I'm going to go back to this tool right here. Diagnose Geometry. So let's go ahead then and look at the options available in this particular diagnosis tool. At the top we see that we have angles used by bad angle checks of 350 and 10 as our thresholds. Those are good angles to check with regards to hex meshing. If you're doing TET meshing, then those angles can be relaxed. It's easier to put triangles in narrow corners than it is to put hexahedra in narrow corners. The available checks that we have are small features, bad angles, overlap checks, poor traits. You'll notice that they're all on by default with the exception of overlapping volumes, which is off by default, and that's because that particular check is potentially expensive. If you were to import a model that contained many volumes, then checking each volume against every other volume in the model for overlap can be time consuming. So we turn that off by default. Another interesting one is the bad geometry definition down at the bottom of poor traits. You can get that badly defined geometry when you import step models, when you import models that are produced, let's say from ProE, for example, and they export a SAT file, because the tolerances in ProEngineer are different than the tolerances in the spatial ASIS engine, then we can get some badly defined geometry. Other things, small features and such, are on by default. Small is related to this value up here, the shortest edge length. Our default value in this particular tool is 1. You can change it to be anything. You might know that Qubit itself is unitless, but 1 implies an edge length of 1. So whatever Qubit decides 1 is, if you've got a feature that is smaller than 1, that means we can't put a hex element onto that feature, right? So anything smaller than 1 is going to be flagged as small in this tool. Let's go ahead and hit the Analyze button and see what we find. So we see a few things have shown up. We've got some situations of close loops, blend surfaces, curves with small angles, and some badly defined curves. So if I select one of these entities, you can see that it'll get highlighted over in the model. It says that that particular surface is small and could be a problem. This particular surface is small and could be a problem. I can see that as a surface by itself. To put hexahedra in there is going to be problematic. Now you can put hexes in there. They'll be very, very, very tiny, and it's probably not what you want in your model. We have these situations of blends that we can see at the top and on this side here. As an analyst, I would look at those particular blends and say, while Qubit might consider those a problem for hex meshing, as an analyst I know that they need to be there. So I'll need to figure out a different solution to work around those blend surfaces. The other one that's interesting down here is these badly defined curves. And they just show up in various places on the model. And that's likely because this model was made by something other than Qubit, which will do native SAT files. The good news there is that those are easily remedied. If we look at the tool a little bit farther down, we see two sections. We have a section of real operations and a section of virtual operations. Real operations in Qubit are any geometric operations that change the underlying CAD. Virtual operations are any operation in Qubit that modifies the geometry, but it does it at a level above the underlying CAD in a layer that we call virtual. Things like composite are part of the virtual operations. And while it fixes the geometry for the purposes of meshing, it does not change the underlying geometry. Back to our badly defined curves. So one of the things that we have here, one of the tools that we have recommended, is to heal the geometry. So I'm going to select that button. You'll notice that on the right hand side of the GUI, the command panel came up, and it is the volume modify heal command panel. Volume 1 is automatically selected. In this particular case, I'm going to go ahead and select auto heal. I'll not select any of the other options. I'll hit apply. This is actually a tool produced by the Spatial. It's in the ASUS engine, and it's specifically to Spatial and will heal these badly defined curves in this particular case. If we scroll up a little bit and see what it told us, it says that before the healing operation, 97% of the geometry was good, and after it was 100%. If I hit Analyze again up here, you can see that that section of badly defined geometry or badly defined curves is gone. As I go down farther, let's look at close loops for a second. We've got that loop and that loop. I happen to know that if there's an operation called tweaking, and it is accessed via this button right here, tweak surface or curve. I'm going to select surface 17 up in the tool. I'll select that tool. The correct command panel will come up. So it is the geometry surface modify tweak command panel. I'm going to go into this pull down, and I know that the remove version with the extend option will actually remove that surface and give me a nice 90-degree corner down there at the intersection of those two other surfaces. So I can preview this. When I preview, you can see that it puts little blue lines on there to show me about what the geometry is going to look like. It's hard to see in this particular case what's going to actually happen, but nevertheless there's a preview. I'll hit apply, and if we zoom in we can see that that's got a nice sharp edge now. If I hit analyze again, we can see that that surface is still there. It's determined now that this surface 18 could be a problem because of the proximity of the curves at this area right here that being very close. I know that the way I'm going to mesh it, I'm going to mitigate that, and it will not be a problem, so I can ignore that. However, I can't ignore this. This is still a problem. So I'm going to use the same tool. If I go ahead and select that and then hit the, if I activate that and then select that, then surface 15 can be removed in the same operation that the other one was. Hit apply. I got that nice sharp edge. If I hit analyze again, then I've got that showing up as a potential problem and these two blends. And like I said before, I know that those two blends are important to my model. They can't be analyzed out. So for now, I'm ready to go into the next step, which would be to decompose this volume via web cutting, and we'll do that in a subsequent section.